Let's begin section 4.2, the least squares fitted line. Now we're continuing learning about linear correlation. Last time we learned more about the conceptual ideas, strong, weak, positive, negative, etc. But we didn't really learn any math. Today we're going to learn the math. In particular, we're going to start off by learning about the correlation coefficient, the correlation coefficient, R, which measures the strength of the correlation between two variables. The formula for R is quite complicated. Conceptually, it's quite complicated to explain, but the basic idea is that R is positive when the correlation is positive, R is negative when the correlation is negative, and R is close to 0 when the correlation is close to 0. In fact, R is a dimensionless measure that is always between -1 and 1, inclusive. R is the same regardless of which variable is explanatory, which means the x variable, or response, or the y variable. If you're a scientist, you might also hear these referred to as the independent and dependent variables, right? So regardless of which variable is x and which variable is y, your line might have a slightly different slope, the graph might look a little different, but R will be the same. By the way, when determining which variable is x or y, you typically want to make x the variable that you're changing or that you want to use to predict the value of y. Right. Sometimes it doesn't really make a difference, like when we were considering the math and reading scores in the previous video. But sometimes it does. If you want to use the age of a car to try to predict the number of miles on it or its worth, you would make the age of the car the independent variable, and then the mileage, the y variable, right? Because you wanted to use the age to predict the mileage. Okay. Also, R is sensitive to outliers. Okay. The following is true for R. If R is greater than 0, then x and y have, as I just said, positive correlation, linear correlation, I should say. If R is less than 0, then x and y have negative linear correlation. If R equals 0, then x and y have no linear correlation. And the closer R is to 1, the stronger the positive linear correlation is between x and y. The closer R is to -1, the stronger the negative linear correlation is. And if R equals 1, then we have perfect, sorry, not perfect linear, I do that every time, perfect positive linear correlation. R equals -1, we have perfect negative, right? Now, this never really happens, or almost never happens, but we might get very close to 1 or very close to -1, okay? Now, so we have our measure. R is the correlation coefficient. Let's briefly discuss the least squares regression line, okay? Now, why do we call it the least squared regression line? Well, let's think about what it is. If we have a set of axes, right, and we have a bunch of points, maybe it's something like this, we want to construct a line that best represents the pattern that these points display with each other and maybe could even predict future y values given a certain x value. So visually speaking, we know the line is going to look something like this, right? But what is the determining factor about how we create this line? You might think, well, it's the line that's closest to all the points. Well, you're kind of right. Technically speaking, the line is the line, and you might think, oh, well, maybe it's vertically closest to the points. And that's getting closer. It turns out the line is the line such that the sum of the squares of the vertical distances between all points in this line is minimized. So all those little dotted blue lines that I drew, find that length, find each of those lengths, square each of those lengths, add them together. That would be minimized by that black line. Okay? And that line has equation y equals, now let's think back to algebra class, right? We know that on the one hand, y equals mx plus b is our equation of choice. The way that it's written in this textbook and in statistics sometimes is beta naught plus beta 1x. I did not come up with that. That's just what the book does. That's what we're going to do. Calculators, you might see it written as a plus bx. I really don't care what you call it, but I'm going to be referring to it as beta naught plus beta 1x. So, that's just how we have to refer to it. Okay? So anyway, just as I was saying before, least squared regression line minimizes the sum of the squares. You don't really need to know that. Just understand it's the best fit line, the best fit curve, okay? So anyway, the least squares line has equation y equals beta naught plus beta 1x. Again, if that's confusing, just write b1, like b naught and b1. But let's be clear about what this means. Beta naught is the y-intercept. So that means that if you plugged in 0, then you would, into this, like in for x, then you would get, I guess I'll just say, y of 0 equals, what is happening? Okay. Sorry about that. That's weird. Y of 0 equals, so pencil seems not to be working. Sorry about this technical issue, guys. My pencil decided to stop working.